Para indan na was.
Over ake sisi deu.
Tahan bertai far-farai magartene.
Waita. Data kushida an.
Ever wondered how Mursi people build waterproof homes using only mud and grass, while modern houses need concrete and steel? These ancient construction methods create structures that last decades using completely natural materials available within walking distance of every building site. Site preparation. Walk into any modern construction site and you'll see bulldozers moving tons of earth and concrete mixers preparing foundations that cost thousands of dollars. Walk into a Mursi home construction project and you'll witness site preparation that uses only traditional tools and natural materials, creating building foundations that support structures for 20 to 30 years without any manufactured components. The process begins with careful ground selection, choosing elevated areas that provide natural drainage while remaining accessible to water sources and community pathways. Ground leveling happens through systematic soil removal and addition, using traditional digging sticks and hands to create perfectly level building platforms without mechanical equipment. Mud mixing. Creating the perfect mud mixture requires sophisticated understanding of soil composition, water content, and binding materials that rivals modern concrete science in precision and effectiveness. Clay-rich soil gets selected through traditional testing methods where experienced builders evaluate soil samples by touch, appearance, and moldability to identify optimal mud-making materials. Water ratios follow traditional formulas passed down through generations, typically 3 parts clay soil to 1 part water, adjusted based on seasonal moisture content and soil density. Binding additives include chopped grass, animal dung, and plant fibers that strengthen mud walls and prevent cracking during drying periods. Mixing techniques involve systematic stirring and kneading that ensures uniform consistency throughout the mud batch, creating material that handles like modern mortar but costs absolutely nothing to produce. Grass processing. Thatching grass requires careful selection, harvesting, and preparation that transforms wild vegetation into sophisticated roofing material, capable of shedding water for years without maintenance or replacement. Harvesting timing follows seasonal patterns, with the best thatching grass cut during dry periods when moisture content is low and stalks have maximum strength and durability. Drying processes involve bundling grass into manageable sheaves and storing them in elevated, ventilated areas where air circulation prevents rot while maintaining flexibility necessary for roof construction. Sorting procedures separate grass by length and quality, with longest, strongest stalks reserved for outer roof layers that face weather exposure, while shorter materials serve interior thatching functions. Quality testing involves bending and pulling individual grass stems to evaluate strength, flexibility, and weather resistance that determine suitability for different roofing applications. Foundation building. Traditional foundations use stone placement and mud mortar techniques that create stable building platforms without concrete, rebar, or mechanical equipment that modern construction requires for structural stability. Stone selection follows traditional criteria including size, shape, and density that ensure proper load distribution and long-term structural integrity under varying soil conditions and seasonal weather changes. Mud mortar preparation involves specific clay to sand ratios that create strong bonding material capable of holding foundation stones securely while allowing slight movement that prevents cracking from ground settlement. Moisture barriers emerge naturally through careful stone placement that creates drainage channels and elevation changes that direct water away from building foundations and interior living spaces. Installation techniques involve fitting stones together like puzzle pieces, using traditional knowledge about weight distribution and structural mechanics that creates foundations lasting decades without professional engineering or expensive materials. Wall construction. Building mud walls requires layer-by-layer construction techniques that create strong, weatherproof structures using applications methods refined over centuries of traditional building experience. Initial layers involve applying mud in palm-sized sections, pressing material firmly against foundation stones while ensuring even thickness that provides uniform structural strength throughout wall height. Grass reinforcement gets embedded between mud layers, creating internal framework that prevents cracking and adds tensile strength that pure mud construction cannot achieve alone. Drying periods between layers allow proper curing that prevents structural weakness, with experienced builders knowing exactly when each layer is ready for additional material application. Wall thickness varies by function, with exterior walls built thicker for weather protection, while interior partitions use thinner construction that conserves materials while providing adequate privacy and structural division. Corner construction uses interlocking techniques that create strong joints without metal fasteners or modern building hardware. Door framing. Installing door openings requires wooden frame construction and structural integration that maintains wall integrity while providing functional access that serves household needs without compromising building strength or weather protection. Wood selection involves choosing straight, strong branches or small tree trunks that resist warping and provide long-term structural stability under daily use and seasonal weather changes. Frame preparation includes careful measurements and cutting that create perfectly sized openings using traditional tools and techniques that ensure proper fit without gaps that allow weather penetration. Integration methods involve embedding wooden frames directly into mud wall construction, creating seamless connection between organic materials that moves together through seasonal expansion and contraction. Installation timing requires coordination with wall construction progress, placing frames at exactly the right stage of building completion to ensure proper bonding and structural integration. Roof structure. Creating roof support systems involves wooden beam placement and engineering that distributes weight effectively while providing attachment points for thatching materials that protect interior spaces from weather exposure. Beam selection requires finding straight, strong wood pieces that span building dimensions without sagging under roof, weight, and seasonal weather loads, including wind and occasional snow or heavy rain. Support placement follows traditional engineering principles that distribute roof loads evenly across place. Wall structures, preventing concentrated stress that could cause wall damage or structural failure. Connection techniques use traditional joinery methods, including notching and lashing, that create secure beam attachment without nails, screws, or metal hardware that modern construction requires. Structural spacing reflects traditional knowledge about load distribution and material strength that ensures adequate roof support while minimizing wood requirements and construction complexity. Thatching method. Applying grass roofing requires sophisticated layering techniques and water-shedding principles that create completely waterproof protection using only natural materials and traditional construction knowledge. Starting procedures begin at roof edges with carefully overlapped grass bundles that create foundation layers for subsequent thatching that builds upward toward roof peaks in systematic progression. Layer thickness varies by roof section, with edge areas receiving extra material for weather protection, while central areas use standard thickness that balances protection with material conservation. Angle considerations follow traditional knowledge about water flow and drainage that ensures rain runs off roof surfaces without penetrating interior spaces or pooling in areas that could cause structural damage. Binding techniques use grass itself to secure thatching bundles, creating integrated roofing systems that require no external fasteners while maintaining flexibility that prevents wind damage. Plastering process. Interior and exterior finishing involves specialized mud applications that create smooth, attractive surfaces while providing additional weather protection and structural reinforcement that extends building life and improves habitability. Interior plastering uses finer mud mixtures with higher clay content that creates smooth surfaces suitable for daily living while providing thermal mass that moderates indoor temperatures throughout daily and seasonal temperature cycles. The interior mixture gets sieved through traditional baskets to remove stones and large debris, creating fine textured material that spreads evenly and dries to a smooth finish that resists cracking and wear from daily household activities. Exterior applications require coarser mixtures that resist weather erosion while providing attractive appearance that reflects family pride and cultural aesthetic preferences that distinguish individual homes within community settings. The exterior blend incorporates more sand and chopped grass fibers that strengthen the surface against rain impact and wind erosion while maintaining flexibility that prevents weather-related cracking. Application techniques involve systematic covering of entire wall surfaces using hand-spreading methods that create uniform thickness and appearance without mechanical tools or expensive finishing equipment. Master builders develop hand techniques that spread mud in overlapping patterns, ensuring complete coverage while maintaining consistent thickness that prevents weak spots or uneven drying. Color variations emerge from different clay sources and mixing techniques, with some families adding natural pigments from local minerals or plant materials that create distinctive appearances reflecting individual artistic preferences and cultural traditions. Finishing touches include surface smoothing and decorative elements that demonstrate individual artistic expression while maintaining cultural appropriateness and structural functionality. The final smoothing process uses flat stones or wooden tools to create surfaces that rival modern drywall in smoothness and durability, while decorative patterns pressed into wet mud create visual interest and cultural identity markers. Ventilation design. Traditional homes include carefully planned air circulation systems that manage indoor air quality, temperature control, and smoke removal without mechanical ventilation systems or electrical equipment that modern buildings require. Smoke hole placement follows traditional engineering that creates proper draft for cooking fires while preventing rain penetration and maintaining structural integrity of roof systems during all weather conditions. The smoke holes get positioned at optimal roof locations determined by prevailing wind patterns and seasonal weather variations, with traditional builders understanding airflow dynamics that ensure efficient smoke removal regardless of outside wind direction or intensity. Rain baffles constructed from curved clay tiles or woven grass shields redirect rainwater around smoke holes while maintaining adequate opening size for proper ventilation and smoke removal during cooking periods. Air circulation planning includes strategic placement of openings and gaps that encourage natural airflow through living spaces, removing stale air and maintaining comfortable conditions during hot weather periods. Low-level intake openings positioned on cool sides of buildings draw fresh air into living spaces, while high-level exhaust openings on opposite walls create natural convection currents that circulate air continuously without mechanical assistance. Temperature management occurs through ventilation design that takes advantage of natural air movement patterns and thermal dynamics that keep interior spaces cooler than outside temperatures during summer heat. The thermal mass of thick mud walls combined with strategic ventilation creates natural air conditioning that moderates temperature swings and maintains comfortable conditions through daily temperature cycles. Sizing calculations use traditional knowledge about airflow requirements and opening dimensions that ensure adequate ventilation without compromising weather protection or structural strength. Experienced builders know exact proportions between room size and opening dimensions that optimize airflow while preventing weather penetration or structural weakness that could compromise building integrity. Weatherproofing. Protecting homes from rain, wind, and seasonal weather requires ongoing maintenance and protective measures that keep natural building materials functional and comfortable throughout years of weather exposure and daily use. Rain protection strategies include roof maintenance, wall inspection, and drainage management that prevents water damage while maintaining structural integrity through seasonal weather cycles that challenge all building materials. Roof maintenance involves systematic inspection of thatching condition, identifying areas where grass has deteriorated or shifted, and replacing damaged sections before water penetration occurs. Wall protection includes application of fresh mud coats before rainy seasons, sealing cracks and thin spots that could allow water infiltration that damages interior walls and structural elements. Structural reinforcement involves periodic mud application and grass replacement that maintains weather resistance while addressing normal wear and aging that affects all natural building materials over time. Foundation drainage improvements include digging channels around buildings that direct surface water away from walls and foundations, preventing saturation that could undermine structural stability. Seasonal preparations include specific maintenance activities timed to weather patterns, with dry season repairs preparing homes for rainy periods, while wet season activities address immediate weather protection needs. Pre-rain maintenance focuses on comprehensive repairs when materials dry quickly and work conditions remain optimal, while wet season activities concentrate on emergency protection and damage control when weather prevents major construction work. Preventive measures reduce major repair requirements through regular inspection and minor maintenance that addresses problems before they compromise structural integrity or habitability. Weekly inspections during weather seasons identify developing problems early, enabling minor repairs that prevent major damage requiring extensive reconstruction. Traditional knowledge about weather patterns and building behavior helps homeowners anticipate maintenance needs and schedule activities optimally. Repair techniques. Maintaining traditional homes requires specialized knowledge about damage assessment, material replacement, and restoration methods that extend building life while preserving structural integrity and cultural authenticity through appropriate traditional techniques. Damage evaluation follows traditional knowledge about structural problems, weather damage, and normal aging that helps homeowners determine repair priorities and appropriate intervention strategies that address problems effectively. Experienced builders recognize different types of damage patterns, from settling cracks that require minor filling to structural damage that needs complete wall section replacement. Assessment techniques include testing wall stability by pressing and tapping surfaces, examining foundation conditions for settling or erosion, and evaluating roof integrity through visual inspection and manual testing of thatching security. Material preparation for repairs uses the same techniques as original construction, ensuring compatibility between old and new materials that maintain structural integrity while providing long-term durability. Clay sources remain consistent to prevent differential expansion and contraction that could create weak joints between old and new construction materials. Grass preparation follows identical procedures to original thatching, ensuring color match and weather resistance that creates seamless repairs invisible after completion. Application methods follow established procedures that integrate repair materials seamlessly with existing structures, preventing weak points or aesthetic problems that could affect building function or appearance. Repair techniques include feathering new mud into existing surfaces, creating gradual transitions that distribute stress evenly and prevent crack formation at repair boundaries. Advanced repairs involve partial wall reconstruction using traditional construction sequences that maintain structural continuity while replacing damaged sections completely. Timing considerations coordinate repairs with weather patterns and material availability, scheduling major maintenance during optimal conditions while addressing emergency repairs immediately, regardless of seasonal constraints. Emergency repairs focus on weather protection and structural stability, using temporary measures that protect buildings until proper repairs become feasible during appropriate weather conditions. Mursi traditional building methods demonstrate sophisticated engineering and material science that creates comfortable, durable homes using completely renewable resources and sustainable construction practices that modern green building movements struggle to match. The future of sustainable construction could benefit significantly from studying traditional building wisdom that creates effective shelter while minimizing environmental impact and resource consumption through ingenious use of natural materials. Understanding traditional construction methods helps appreciate indigenous knowledge systems while providing practical alternatives for sustainable development that serves human needs without damaging environmental systems or exhausting natural resources.